Okay, so let's start our lecture today. So, last time, we are left to show the. So there are two parts, right? So one part is about the zeta function, and then the residue part, and the other part is about the integrating over the boundary part and its correlation and for with the with the angle part. Okay, so let's focus on so here. So this is a question of why the residue of the zeta of the zeta node zeta zeta z equal to 1. Okay. So yeah, so we have that yeah, so yeah, and then we talk about the idea of separating the singular part and non-singular part, right? So yeah, the question is that what is the Laurent series of this zeta of z naught zeta z at zeta naught. So and then we mentioned the idea is that separate the singular part and singular and non-singular part. Okay. Okay, so okay, so okay, so let's set it aside for a while because I want to work on the I want to work on the angle part first. Okay, so let's see. So so the other part. So this is the like some two separate part of the same problem, right? So well, like we separate this small problem aside. So our main problem is so why the 1 over 2 pi I integrating over the boundary of the parallelogram dz over z minus z naught zeta naught, right, is equal to 1 over 2 pi of the change of the angles over the boundary of the parallelogram of z minus zeta naught, where z goes through the boundaries, and we will care about the change of the angles of this quantity, which is equal to 1. Okay. Yeah, so let's see what the AI say about this one. Okay. Okay, so it's still loading. So, oh, it's loading. Okay. Okay, the answer is, okay, so that gamma from this AB to this C minus zeta naught be the boundary curve of the parallelogram. Okay. So here we have z is equal to this gamma of t, right? Okay, and then we define this w of t to be equal to gamma of t minus zeta naught. Okay, so then since so we have that gamma t, this boundary does not pass through zeta naught, right? So we have that this guy is not equal to 0. Okay. And then okay. So okay, so therefore we can write along the curve omega t is equal to RT e to the I theta t. Okay, so where RT is just the radius, right? Okay. Okay, so okay. And then yeah, so where this RT is just the modulus, right, of omega t, which is positive. And also theta t is a continuous choice of argument along the path. Okay, so then okay, so then we have that this dz over z minus zeta naught is equal to d omega over omega. So by okay, so okay, so okay, so yeah, so I was having a question. So why there is yeah, I was thinking of why there is a continuous choice of the argument among the paths, right? So because yeah, we can just let for each t that, right? So we can just let theta t to be equal to the angle between 0 and 2 pi, right? So that's so that is so continuous choice. So why this is continuous? Because RT is continuous, right? Yeah, so why this is continuous? So if I take the limit as t goes to a point, yeah, so we can just show that the limit is approaching to the limit. Yeah. Yeah, so let's see. So for each t in this 0ab, we let okay, theta t to be equal to just the arctangent, right, of okay, so okay, so what do I really want? So okay, so here this is a parallelogram, right? So so here for each t, I have the gamma t as that, which is equal to, let's say, x comma t comma y t, right? So so this angle should be equal to the so this is the angle theta. So theta t. So the hypotenuse, sorry, the opposite is like the yt, and then the adjacent is like the xt. So when we are doing the arctangent, so what should we really get? Yeah, I think sorry, I forgot what is the arctangent. So okay. So tangent is opposite over adjacent, right? So tangent of theta is equal to yt over xt. Okay, so opposite over adjacent. So okay. Yt over xt. Okay. Okay, so and then okay, and then since RT is continuous, right? We know that this so this implies that Okay, so this implies that xt and yt are continuous. Yeah, you can show it by taking the limit as t approaches to t naught, and then yeah, so and then this x minus x naught taking over the norm is less than or equal to this r of t minus r of t naught, right? Right, so which is less than the desired yeah. So we can control it. We can control this x, the differences between xt and xt naught by this rt and rt naught. Yeah. So yeah, so this implies that yeah, so this implies that this yt, since xt is not equal to 0, right? Okay. Implies that this yt over xt is continuous. Okay. Yeah. So then arctangent is continuous. Implies that is continuous. Implies that wait, let me make sure. Okay, yeah, arctangent is continuous implies that this theta t is continuous. Okay. So yeah, so we have that, and then so dz over oh gosh yeah, I was confused about so what does it mean by dz over this guy in terms of complex number? So z is gamma t, right? Okay. It mean by dz. Okay. Yeah, I think one way to see that is hold on 1 second. Yeah, so what does it mean by dz? Yeah. Okay, so yeah, so what does it mean by dz over z minus zeta naught, which is equal to d omega over omega. So I think one way to see that is dz over z minus zeta naught, right? So which is equal to wait. Yeah, so I have to look for what does it mean by integrating over this dz over okay. So integrating over dz means that so this is equal to this gamma prime t dt, okay, and then this is equal to wait, I'm not sure. So let's see. Let's check it carefully. Okay, let's check it carefully. So, okay. So where is my So it is here. This maybe it's here. No. Let's see. So this is two. Okay, so okay, so this is one form, right? So okay. Okay, so yeah, so this is a little bit, yeah, so it's yeah, so this is yeah, so maybe let me do this. So 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 this is the one form. Okay. Is equal to okay, so dz at gamma t over this is gamma t minus zeta naught. Okay, so this is equal to, yeah, so this is equal to exactly gamma, this is gamma prime t, yeah. So this is dz applied to gamma prime t, which is exactly gamma prime t. Okay. Sorry, this should be dt. Okay. This is times dt. And then, so what is d omega? Over omega. So d omega is so what is d omega? Gamma prime t e to the I theta t plus gamma t e to the I theta t times I theta prime t dt over gamma t minus theta naught. Wait. Wait, that makes sense. Because okay, so what is d omega? Yeah, so what is yeah, I know that dz is one form, but d omega. Okay. Okay, so here we view this omega as a function of t, right? So then d omega is just like df, right? So okay, so d omega is what? So d omega is okay, so by the definition of the differentials, no. Okay, let me ask. Okay, so here, I was not sure how do I view the d omega over omega. So I know that this dz is is a differentials which being defined as dx plus I dy, right? So, but for the d omega, so if I view this omega t, so the wt as a real valued function, right? sorry, not real valued, but complex valued functions. But the input for this omega is just the t, right, between A and B. So so should I view this d omega as just the just the one form to be in terms of dt? Is that how we define this d omega? Because when I view this dz over d minus zeta null, right? So I view it is as a differential form of degree 1, right? Or like one form. And then but how can I view this d omega as a one form? Right. So where this dz, I know that this dz is basically dx plus I dy. There's no problem, but I don't think there's a canonical way to define what is really d omega under the change of variables from z to omega, especially when this omega t has some expression. Yeah. So can you help me with that part? Okay, so okay, I think I maybe need to pause for now. So maybe let's continue next time.